Good morning guys. Today we are going to have a case study about the product which we have printed using 3D printer. This is something like additive manufacturing. You can ask the question, we can have the discussion about this product.
Why did you especially choose this hydraulic field?
Actually the thing is many frictional components and non-frictional components are trying to manufacture using fused deposition modeling. So for that purpose we are just have an attempt to print the hydraulic journal bearing through 3D printing, but this is just a prototype model. We cannot be able to directly implement in the metal type component, but we can implement where the place the polymer bearing can be obtained and which can able to be generate very low friction compared to the existing product friction.
Okay, what is the material for this product?
Actually we have printed using PLA material, which is nothing but polylactic acid. This is very commercially used polymer, which the example of the PLA is where we are using our phone case, computer keyboard type and mouse, and related to the structure we are printing using the PLA material. Also compared to other fused deposition modeling polymer type material, PLA will have the vital role based on the requirement of the customer, and also eco-friendly polymer. Compared to other polymer, PLA will be having high recyclable rate, so we have preferred PLA material for this process.
And also, what is the parameter and what is the time taken to finish this product?
Actually, there are many parameters available in 3D printing. For parameter optimization, parameter control, we can able to use the software called sizing software, in which Curiosity open source sizing software, through which we can able to develop many product with many parameter optimization. Here we have used Curiosity sizing software for this product. For this product, we have kept the infill percentage of 50%. And also we have chosen the layer thickness of 0.15 mm, so we can able to get the fine smooth finish. So in order to control the surface roughness in the product, we need to improve the layer thickness, so we can able to get a super fine finished product. This is the product which we have printed for the sample demo model for a project which our final year students are doing. So for this purpose we have just printed out. In order to check the strength, compression and tensile, we can able to test using the standard testing specimens.
What are the main high polymer products?
Actually, high strength polymer, low strength polymer are basic difference based on their application. In high polymer, which is commercially used or existingly used in related to the automobile manufacturing component. For example, we are using bike, car, mainly two-wheelers and four-wheelers, through which many of the polymers are having high strength polymer, which is nothing but ABS or PEG, and then nylon. These types of material can be used for high-end polymer. And for low-end polymer, the component which we are using for the commercial purpose, such as water bottle, water can, and the water cap, like that, simply commercially available product we can use for the lowest strength polymer, because it's not required as much strength as we are planning for that.
What is the melting point of the?
Actually, for PLA, the melting point will be around 180 degrees Celsius. Until 180 degrees Celsius, the product will be melted, and then suddenly it will be solidified within the temperature of 70 to 75 in the bed temperature. This will be the bed temperature. So we can able to print the product by maintaining the temperature difference inside the chamber by the difference of 180 to 75. So within that time, we can able to solidify the product easily.
Time taken.
For this type of product, we can also able to scale by smaller and larger, but this is the exact dimension of the product for a hydraulic journal bearing. So for this product, the printing time about 2.5 hours, it consumes about around 2.5 hours. For normal manufacturing process of these types of polymer, this is about around 2 to 3 minutes only, because by using injection molding or blow molding only, the polymer type of journal bearings has been manufactured. So in order to overcome injection molding or blow molding, we have to increase the strength of the 3D printed model using FDM machines.
Okay, will the FDM play a significant role in future?
Well, comparatively with rapid prototyping or rapid manufacturing, we can able to go for FDM, but for commercial manufacturing or for mass production, it is still in lag. But even we can say after 5 to 10 years, it can be a mass production. But the thing is, it is not giving the maximum strength as we are having existing product. So this is what the component drawback, and this is what the technology drawback of the 3D printing. So once the component has been manufactured and get the huge strength using FDM machine, we can able to go for the mass production.
Okay, thank you for the cooperation, sir. We will do a about a project, and we will do our final version upcoming days. Thank you.
Okay.